Hello, everyone. Welcome to the webinar. The title of the talk is Life Cycle Assessment Study of High Entropy Alloy Geo-Coat Technologies Deposited Through High Velocity Oxy-Fuel Thermal Spraying, Laser Cladding, and Electro-Spark Deposition Processes. My name is M.A. Hai Chaudhary. I'm the presenter of this talk. The contents of the talk are introductions, life cycle assessment, results, and discussions, and finally, we conclude our results. In the title, we see that there is a term, what we call Geo-Coat. So what is Geo-Coat? Geo-Coat is European Union Horizon 2020 funded project under grant agreement number 764086. Its excellence lies in the concept of developing innovative synthesized coatings referred to as Geo-Coat technology, combating corrosion, erosion corrosion, and scaling damages occurred in geothermal components due to aggressive environment of medium to high temperature geothermal resources. So this is the concept of Geo-Coat. So in this study, what we do, so we are evaluating environmental footprints of Geo-Coat technologies. So we understand what are the Geo-Coat technologies. Geo-Coat technologies are the innovative Geo-Coat coatings deposited on Geo-Coat substrate. And we apply these innovations into the geothermal components where scaling, corrosion, erosion damage occurred in geothermal power plant. So what would be the benefits of adoption of Geo-Coat technology alternative to recommended SO materials for geothermal components? In two areas mainly, levelized cost of energy and environmental impacts. So we expect that for the adoption of Geo-Coat technology in geothermal components can reduce the levelized cost of energy and also can reduce the environmental footprints. In this study, we are studying various types of coating materials deposited on substrates and using three different deposition processes. So before we move on to the details of the study, we have to understand the method, how we evaluate the environmental footprints. So the method we followed here is life cycle assessment. So what is life cycle assessment? So life cycle assessment is a method that provides a holistic approach to evaluate environmental performance by considering the potential impacts from all stages of manufacture, use phase, and end of life stages. There are various frameworks of performing LCA, but the primary and globally accepted way of doing this, ISO LCA standard, which is 14,000 series. So in this ISO LCA standard, there are four major phases: goal and scope, inventory analysis, impact assessment, and interpretations. So what is the goal of LCA studies for synthesized coatings? The ultimate goal is to be identify the green and sustainable synthesized coatings. And then what would be the scope of the study? So we conduct cradle to gate LCA study for considered synthesized coatings. So there are 5 high entropy alloy coating materials we have considered. 3 deposition processes we have considered to deposit these 5 different types of high entropy alloys. And before we deposit the coating materials, we apply substrate surface preparation methods. So I would like to mention here, so we have used 5 different high entropy alloy coating materials, which has been manufactured through 2 different manufacturing process. One is a mechanical alloying method, another is gas atomizing method. And then second stage of the LCA study is about data inventories. So this stage actually a time-consuming stage. We have to collect the data from the primary sources and the secondary sources about the coating materials, about the deposition processes, about the substrate surface preparation processes. We also used EcoInvent database version 3 for materials and processes involved, such as electricity, such as transportations. All the data were normalized, what we have collected from the primary and secondary sources for different synthesized coatings. We have to normalize the data in terms of a functional unit, which we defined 1 micron thick coating over 1 meter square substrate area. And then all this data to be imported into the LCA tool. What we have used is CIMAPRO 9.0049. Third stage of the LCA framework is about impact assessment. So what is impact assessment? So impact assessment, the function of the impact assessment is to be translate and linking all types of LCA results what we have invented to 4 endpoint damage categories: climate change, ecosystem quality, human health, and resources. Here, in this study, we have used impact assessment method, Impact 2002 plus version 2.14. So several impact assessment methods that are contained in the CIMAPRO LCA tool. I would like to mention that. And finally, we got, after carrying out the LCA study using LCA tool and considering the impact assessment methodology, we have the final results what we intend to get. So for environmental footprints, you can see from the bottom of the figure: human health, ecosystem quality, climate change, and resources. This is common name what we call the endpoint damage categories or environmental footprints. We express this one as a percentage. We considered here 5 different synthesized coatings. All are deposited through laser cladding deposition process, and each of synthesized coating has same functional unit. What I mean, 1 micron thick over 1 meter square area. So we considered the worst performance achieved by the high entropy alloy 3 coating material, synthesis coating material. And we consider this one as 100%. So with reference to this one, we can see the performance of other coating system. So if you look, each and every coating system has 4 different damage categories. What I mean, the 4 different environmental footprints. If we focus on one of the major important environmental footprints, what we call climate change, this is the green one. So you can compare how much environmental, I mean that carbon footprints you can save to using the lower environmental footprint synthesized coatings, I mean lower carbon footprint synthesis coatings. You can say that this is about 60% and this is about 100%. So you can, so instead of using the high entropy alloy 3, you can save the carbon footprints about 40% for 1 micron thick over 1 meter square area of coating. So if you use more thickness, if you use more area of coating, then you can saving more, right? So you can evaluate the how much carbon footprint you could save to use the least environmental footprint of synthesized coatings. So from here we understand that, so laser cladded high entropy alloy coating system, what we call the Geo-Coat technology, demonstrated the least environmental footprint as compared with the other 4 synthesized coatings. We can demonstrate these results in terms of a the deposition process. So we know that our best coating material is high entropy alloy 2. So why it is best? Because the high entropy alloy 2 has been manufactured through gas atomizing method. Other high entropy alloy materials have been manufactured through mechanical alloying method. So gas atomizing method requires less energy, less resources, and also the composition of the high entropy alloy is required less energy and then less mass flow. So that is the reason. Those are the reasons for giving us the lower environmental footprint. Now we wish to see what would be the impacts due to the different deposition processes. In this study, we are dealing with the 3 deposition processes. So here we consider only one coating material, which is the least environmental footprint is demonstrated in figure 1. So in figure 2, we choose the high entropy alloy 2 coating material deposited through 3 different deposition processes. And these are the results in terms of environmental footprints. So what we have seen here, we can see here again, as compared with the other 2 synthesized coating system, which are deposited through HBF thermal spraying method and Electro-Spark deposition method, the laser cladding deposited high entropy alloy 2, demonstrating the lower environmental footprints in all aspects. I mean, in all 4 damage categories. So these are the results what we have got, right? And finally, we can conclude our results from the LCA results. So what we have been concluded, so Geo-Coat technology laser cladded high entropy alloy 2 demonstrated lower environmental footprints as compared with other Geo-Coat technology studied. Hence, it is estimated that about laser cladded high entropy alloy 2 showed about 55% carbon footprint savings as compared with high entropy alloy 2 synthesized coatings. So therefore, it is worth mentioning that this Geo-Coat technology not only green and sustainable, but also demonstrated as best candidate of Geo-Coat technology for different application areas such as pipes and casings, turbine components to protect against corrosion and erosion damages. Thank you for the listening.